Okay, so we're looking at the exam style practice paper from the first year textbook, and we're on question 13. Okay, so we've got a binomial expansion question. So expand in ascending powers of x, it's pretty much always ascending powers of x, up to x squared, and then we've got to simplify each term down. So you are given the binomial expansion formula. So this is the formula sheet that you're given in an exam. Okay, so it's nice and straight, relatively straightforward. You will still need to obviously have practiced it a lot though, because just having the formula isn't going to sort everything out for you. So, okay, so I'm expanding 1 minus 3x to the power of 5. So it's 1 to the power of 5 plus, from 5 choose 1, and then 1 will be to the power of 4, and don't forget the minus. So I always use brackets rather than multiplication signs, because it just makes it so much easier to see what each of my individual terms are. So the third term is going to be from 5 choose 2, 1 to the power of 3 times minus 3x all squared. So if you sort of are not bothering writing the powers of 1, that's absolutely fine, because they are going to equal 1. And if you didn't bother writing the power of 5, that is absolutely correct. If you're feeling confident, if you're sort of still just a bit, hopefully you're not unsure about binomial expansion, but if you prefer just to have the whole thing written out so you can clearly see the patterns, then that's absolutely fine. So I would, make sure I could do it without the formula sheet there, but obviously you can have it just as a reminder. So for us, A was 1 and B was minus 3x. And then the most important thing, particularly, with B, is that you have brackets, okay? So now, and it did say to simplify, and you always will need to simplify. So 1 to the power of 5 is just 1, so that's fine. And then, so for my second term, 5 choose 1 is just 5. And then 1 to the power of 4 is just 1. And then I just got to be careful with that minus. So the fact that it's a minus actually means the whole term is going to be a negative, so I would just put a minus there. And it's 5 times minus 3. Okay, looking on to the next term is going to be a positive because I'm squaring the minus 3x. So that is going to square to positive 9. So that term is going to be 5 choose 2. So you can just get that from the calculator, or you might remember Pascal's triangle, but that gives me 10. And then the minus 3x all squared is 9x. So that is going to give me 90x squared. Again, obviously the expansion does go on. There would be an x cubed term, an x to the power of 4 term, an x to the power of 5 term, but the question only asked me to go up to x squared. Okay, so then B, hence find an approximation for 0.97 to the power of 5. Right. So this is what I expanded, and I'm supposed to use this to come up with an estimation or an approximation for 0.97 to the power of 5. So these questions only really make sense. Oh, one thing, sorry. Right. These questions only really make sense if those powers are the same. Okay. And then basically what I'm trying to find is, well, what value of x would make 1 minus 3x equal 0.7? So if I minus the 0.97 from the left-hand side, and then I divide by 3, I get x is 0.01. And x should always basically be a power of 10. So 0.1, 0.01, 0.001, because the idea is we could, so just move this out the way, we could substitute. So if I go back to my expansion, So this answer here, I could substitute x equals 0.01 in without using a calculator. So it is 1 minus 15 times 0.01, okay, plus 90 times 0.01 squared. Okay, so I'm just substituting 0.01 into that. And that is something I could work out without a calculator. I'm not going to because I've got a calculator, but that's why we have this as a method. So 1 minus 15 times 0.01 plus 90 times 0.01 squared. Okay, so that is giving me 0.859. Yes, it didn't mention rounding. That is completely rounded. The other thing I can do, just to check whether that seems realistic, and I wouldn't even write this down in my working, but if I work out what 0.97 to the power of 5 actually is, if I just put that into the calculator, it works out as that. So that check there, so in fact I wouldn't write that in my working, I would just put that onto the calculator. So I won't leave that as part of my working, but they should be quite close to each other. So that makes me as confident as I can be that my answer is okay. So that's my answer to part B. And obviously I would need all the working, because if I just plugged 0.97 to the power of 5 into my calculator, I actually did get that to 3 significant figures. So if I've only got that written down, they won't know that I've used the correct method. So you do need to show all the working. State with a reason whether your approximation is greater or smaller than the true value. Okay, we can't see, well, I can't see on the online textbook how many marks that's worth. Right, so why is our approximation not totally correct? Well, it's because we didn't so I'm looking back at this line here, and we only went up to the x squared term. So that's why it's not totally accurate. It would, if we did it all the way up to the x to the 5 term, it would give us the complete right answer. So what would happen if we did carry on? So we've got the 1 minus 15x plus 90x squared. Well, my next term would be minus something x cubed, then plus something x to the 4, then minus something x to the 5. So when I'm saying something, I'm meaning I'm not going to bother working out those coefficients. But I do know that the x cubed term would be negative, because when I cubed negative 3x, it would come out as negative. When I do negative 3x to the power of 4, it will come out as positive. When I do negative 3x to the power of 5, it will come out as negative. So I do know that the x cubed, I keep hitting the wrong thing, the x cubed will both be negative terms, and the x to the 4 will be a positive term. So the x cubed term will be larger than the x to the 4 term, because every time I increase the power, this is going to move down one more place value. So if you follow that logic, state with a reason whether your approximation is greater or smaller. Our approximation will be greater, because the true value would have minus the x cubed term. Okay, let's just have a look at what they've put, because they might be a little clearer than my explanation. Okay, so the next term will be subtracting. Let's try and get it on the same, roughly on the same page. What's it going to happen? In fact, there we go. Right. So the next term will be subtracting, and we know that because we know it's going to be minus 3x all cubed, so that will still be a negative. The x to the power of 4 term will be a positive, or will be adding, but it's going to be smaller than the x cubed term. Okay, so that's why our actual answer is greater than the exact answer.